So in last session, we had seen what is AWS, what is a cloud, and what are the services provided by the cloud. In this session, we are going to see a first service by AWS is IAM, Identity and Access Management. So first we're going to see what is the IAM service. So what it basically manages are the users, groups, policies, and roles, and some of the additional features of the IAM and IAM best practices. Okay, so let's get started. So whenever you want to work on AWS, so before working on AWS, you will need account to work on AWS. So you can just go to the aws.amazon web services. You can just sign up over there and you can use your services. So assume that you have created account on AWS and you have the three services running. So some of your storage services, some of you are MySQL service, that's your database services, and some of the compute services. And you are the only person who have access to your account. You are only person who knows the credential of your account, right? And if only you knows the credential of your account, then you are the responsible for managing this all kind of things, managing the storages, managing the databases, and managing the your compute devices, right? And you know that any person single-handedly cannot manage everything. You can't manage databases, storages, and the compute devices at the same time, right? So you will not be available over there for 24/7 for managing all kind of things. So you will need a team who will manage this whole stuff. You will need a storage team which will manage your storage devices. You will need a database team which will manage your databases. You will need a compute team which will manage the compute devices. Again, it will be a Linux machine device, Linux devices. Again, it will be a Windows devices, right? And if any person wants to access you some such kind of services, they will also need credentials, and you just have one credentials when you create an account. When you signed up on AWS, you got some credentials. The credentials are your email ID and your password. And you can't share the credentials because if you share the credentials, the person will get authority to manage everything, right? They can manage all the things. They can manage S3, they can manage RDS, they can manage EC2, Linux machine, Windows machine. They can manage everything, right? And it will be not easy to auditing as well for the auditing as well. Like if some person did something wrong, you will not get to know who did that thing because all logged in with the same credentials, right? If anything, if any service got deleted, if any service got stopped, you cannot audit such kind of things, right? So what we have on AWS, we have the identity and access management. So if this is your root account, and in that account, if these are your services, so first create account is your root account. And if these are your services, so for the managing that services, you can create some IAM users. So IAM users like a storage admin is one of your IAM user, database admin is your other IAM user, system admin is your third IAM user, right? A storage admin wants a permission to use S3, database admin wants a permission to use RDS, and system admin wants a permission to use EC2. Because whenever you add a user into your account, they will not have any kind of permissions. They will not have any kind of authorities to manage, right? So it will be your task to provide them authority so they can manage the services. And these authorities can provide it with the service called as IAM. So with IAM, you can create a policies. Like first of all, you will not have any type of permissions, right? And with the policies, you can provide the permissions to the user. So you have to create a document. A document you can write in a notepad or WordPad in any kind of editor. Write a document and attach that file to the storage admin. So you have to write in the document that this user needs a permission on this particular service. You have to write down this in some specific format, right? So my user needs a read permission on this service, write permission on this service, list permission on this service. So you have to write down everything over there in the policy. Attach the policy to the user. then only the user will get permission to manage the particular service. The same thing for database admin. So for database admin, you have to create other policy, create a policy, attach a policy, and then only database admin can use the service. Same for the system admin as well. Create a policy, attach a policy, then the system admin can use the EC2 service, right? So every user will have the separate policies, right? And what is written in the policy? The access, what type of access the user have, the authorities, that will be written in the policy, right? So here we got to know three things. The first thing, the IAM user. The IAM user is a part of your account. It's a part of your account which can be accessed by the separate users, the individual users, individual persons. So they can use the credentials, like the IAM is not just a credential, they are the username and password. So they can use the credentials and they can log in and they can manage the services. The policy, which we use for the authorities, and the resources. The services are called as resources. Everything that you create on AWS, it's a one kind of resource. If you're creating S3, it's a resource. If you're creating any master device, it's a resource. If you're creating any instance or virtual machine, it is a resource. So everything that you create on AWS, it is called as a resource, right? So what's IAM is? IAM is a service which manage your authentication and the authorization. So authentication you can consider as whenever you want to log in to the account, you will need your username and password. That is authentication. After logging to your account, what things you can manage and what things you cannot manage, that we call as a authorization. That we call as authorization. This also can be managed by the policies of the IAM, right? And with the authorization, it limits the access on the AWS resources. So what you can manage and what you can't manage. So you can limit the access, right? If there is a user who is a Linux admin, so the person can only manage the Linux devices. The person is not authenticated to manage the Windows devices. If any person who manages the Windows machines, that person cannot manage the Linux machine. That person can only manage the Windows machines. So that kind of access, that kind of limits you can set for particular person. Then the first account that you will create on the AWS, so that will be your root account. That is considered as your root account, right? A root account, just like a Linux have the root account, Windows have the administrator account. So these kind of accounts have full authorities. So they have all type of permissions on their accounts, right? And because of that, it is never recommended to use a root account. Because if you are using the root account, it will be not easy for the accounting mechanism. You cannot do accounting if everyone is using root account, so you cannot see that what the users are doing in backend, because you will just get to know it's a root account, but who was the root account, you will not get to know. That's why it's not recommended to use a root account in a day-to-day life, right? Create an individual user and assign an individual user per person, and the person have to use that individual user to log in and to do their work, so you can do the accounting of the each person, right? And then the IAM is a global service. So we had seen the global infrastructure last videos. So the global infrastructure was your availability zones, regions, age locations, all kind of things, right? Whenever you create any user on AWS, a user can work on any region, right? If any of the region goes down, if any of the ages goes down, it will not affect that user. User can still log in the AWS console, right? So that's why the AIM is a global service, because it's not dependent on the particular region or particular availability zones. If it is down, if the region is down, it will not affect anything on the service, because whenever you create a user will be registered all over the world. So the user can log in from the any region, you can work on any region. Depending on user must need a policies to work, right? So that we call that why we call it as IAM is a global service. Then what basically IAM manages? So the IAM manages these four things: groups, policies, and roles. The users are like uh, a person who can log in to the AWS console, that is called the users. A group of the users called policies. Sorry, a group of the users called as groups, right? The policies, using that we can provide a permission to the user, and the roles, which are some advanced, it's a collection of some policies and the users that we call as the roles. For now, you can consider as. I'll show you why we use the roles, right? So let's start with this. So user, as I said, it's a person who is going to access the AWS resource, an individual person, right? Because every person will need their separate credentials, so you can manage the limit on that on the services, right? Limit on the permissions and the auditing of the user, or the accounting of the user, right? So that's why every user will need their separate credentials, and the separate credentials can be created by the users, right? So if user got its credentials, the user can log in by two mechanisms: a console login and the API or the CLI login. A console login is easy. Just go to the aws.amazon.com, put your username, put your password, and you will be in. It's a whole graphical way to manage AWS. The other thing that you have, the API or the CLI way. The API or CLI, that's a command line interface way. You can use your command prompt, your Linux terminals to manage the AWS via command line mechanism, right? With the commands or with the APIs, you can access the each and every service of the AWS, right? And for this, you will need access key and you will need a secret access key as a credentials to manage, right? So whenever you want to manage console way, you have a username and password. Whenever you want to manage the API CLI, you can use the access key and a secret access key to manage that thing, to manage with the CLI, right? And whenever you add any user, so newly created user does not have any kind of access by default. You can provide access with a policies, but by default, it will not get any kind of access. User can just log in and log out from the AWS console, nothing else. So all things are denied by default, right? So that is the user. Next, these are some of the examples users that you can add, like the user who manages my database admin, a storage admin, the accountant, a developer, a tester. So I can add such kind of users. But in any case, if I have multiple database admins, multiple storage admins, multiple accountants, multiple developers, multiple testers, so that time it will be hectic for the particular person to provide a permission for each and every user. Providing permission separately for 10 database admins, for 5 storage admins, for the accountants, for developers, right? Again, revoking the permission whenever need, right? So it can prone to the errors if you're not using it carefully, right? And it will add some extra burden on the user who is providing the permission if you have multiple users. That time we can use a groups. A group is a collection of all the IAM users. So whenever you got a chance, whenever you got a task to manage the permission, to provide a permission to multiple users, so at that time just go with a group. Create a group, add all the users into the group, and directly provide a permission for the group, right? So for providing permission for the multiple users, you can easily use the group. Users who are in the group are automatically associated with the policies of the group, right? So you just provide a permission to the group only. Then some of the examples, like instead of creating these users, what we can do? Create these groups. Create it as admins, create a storage admins, create accountants, create developers, create testers, and after that, add the users into these groups, right? So it can be helpful for assigning a permission and again revoking a permission as well. Next thing is policies. Now you have a group with you have users with you. The next task will be providing a permission to the user, right? Because without permission, user can't access any kind of services on the AWS console. So how to provide a permission? So the providing a permission can be done by the policies. So policies are some set of rules, like uh, it may be a permission grant or permission denied. So you can grant a permission for the user to do particular thing, or you can deny the user to do particular thing, right? So these are some set of rules which is written in a document, which is written in the file, right? And that must be written in a JSON file. A JSON is a JavaScript object notation where the policies are written, right? After writing a policy, it can be attached to the user, it can be attached to the group, it can be attached to the rule as well, right? Which manages the authorization of the AWS. So we see in the authentication for adding a users, providing a credentials to them, authorization with the policies. So with authorization, you can provide permissions to the user to do something, or we can deny the user to do something with a use of policies. And let's take a small example of the policy, right? And very easy to understand. This is called a JSON format where you have key and value pairs. So first is my statement. My statement is like this. First is SID is a statement ID, right? Using the policy, I may have multiple statements. So every statement will have the statement ID. And it is any kind of name or the number you can use over there. A collection of number of name you can use for this for the identification of the statement. So for this, I use a visual editor because this policy is created by the visual editor. That as well, what's a visual editor? Effect, it may be allow, it may be a deny. If you want to provide a permission to someone to do something, that is allow. If you want to deny, then maybe a deny. It may be allow, it may be deny. Action. So what kind of action user is granted for? So user is allowed to do this thing. Put object, create bucket, list bucket, delete object, and delete bucket. On what? On the service called as S3. So S3 is a service which just work like a Google Drive. Now you can just consider the Google Drive is a S3, a simple storage service. What we do with Google Drive? We create an account, we upload our data, we manage our data, we share our data, and we delete our account. That is the life cycle of the Google Drive of the Gmail account. Same thing you just consider with S3. So if there is a user can create a bucket, user can upload the data to the bucket, user can delete data from a bucket, user can list the bucket, and user can delete the bucket, right? So this is the action user is granted for, right? And then the resources. Now, if I'm working on a project, the project may have multiple buckets. A bucket for my media files, a bucket for my backup files, a bucket for my snapshot, a bucket for the archival data. I can have multiple buckets. And if user is asking for me permission, so I can't provide a permission for each and every bucket because I can have a sensitive data, I can have critical data in my buckets. So I cannot provide permission to each and every bucket. That time this statement will be useful for you. That's a resources. Resource for which bucket, on which bucket you want a permission. If there are multiple buckets, I need a permission on a particular bucket. So that will be added into the resource. And a resource also has some specific format to write. Resource you have to put in the ARN, Amazon resource name. And the format of Amazon resource name is like this. First ARN, colon, AWS. This is common for all the resources. A resource may be anything. Maybe a bucket, maybe a user, maybe a policy, maybe a virtual machine, it may be anything. And the format will be same. First ARN, then AWS. Right? It's the same for all. Then the service name. In this case, the service name is S3. After that, there are two colons. The first colon is for the account and the other one for the region. There will be account ID and the name of region, maybe like the Paris region, the Ohio region, Mumbai region, like the region name over there. And then the actual name of the bucket that you had given while creating the bucket. Like when you're creating a bucket, you will give the name for the bucket for the identification, and that name will be added over here, right? But if you're thinking of why there is no account ID and why there is no a region name over here, a reason is for that the S3 is not dependent on the particular region or the particular account. It can be managed by multiple accounts and it can be managed by multiple regions. It's also a global service, one of the global service, right? So that's why with the S3 service, you will not get to see any kind of name of account ID or the region name in the ARN. But I will show some ARNs as well for the virtual machines, for the users, for the policies, where you'll get to see the region name and the account ID, right? So that's the basic policy, example policy. And you don't have to write it. If you are good with a JSON, you can write it. If you are not, you have a visual editor available. It's a graphical tool, and you just have to work with the drag and drop method. Select what you want to allow, what you want to deny, drag and drop your services, just select your actions, select your resources. That's it. Click on create. It will create a JSON format in backend. So you don't have to write it by word, right? So this is the example policy that you can use, that you can create and you can attach to the user. Whenever I am attaching this policy to the user will get a permission to do this. If I'm attaching policy to the group, so group will get a permission to do this thing. A users in the group will get the permission to do this kind of things, right? Using that, we can set the authorization of the user, right? So that's the policy. Next thing is a role. Now, role can be used for these four kind of things: a resource access, cross account access, identity providers, and a single sign-on. Can be used for the four mechanisms. The first is resource access. Assume that I have a Linux machine and I have a S3 bucket. So what I want to do, I want to take a backup of my machine to the S3 bucket in a periodic way. Like every day at 6 p.m., I want to take my backup from a machine. So I have created a script, right? I have did all the configuration of my machine, but whenever there was a time for the uploading the data, I got a message access denied. I got an error called access denied. Why I got this? Because these are two different services or resources. Amazon EC2 machine is a different resource and S3 is a different resource. And by default, any of the resource cannot communicate with the other resource directly. You cannot communicate, you cannot add any instruction, you cannot provide any instruction to other services, other resources. This is due to security reasons. Let's say if there is any machine is online and if machine got hacked by someone, so the person who hacked the machine can access all the resources into your account if you have such kind of permissions, but we don't, right? So if any of the machine got compromised, so other services cannot be compromised with the because of the particular machine, right? So by default, you one of the machine does not have access to the other machines or the other resources, right? And for providing the access, we have the roles. So you have to create a role, attach a role to the user or to the machine, then machine can access my other services. So it may be any kind of services. If SQL service want to access S3, if SNS service want to EC2 machine, so whenever your one resource want to access any other resource, want a permission for any other resource, you must need a role in between, right? One service want to access other service, you will need a role in between. That is called as resource access. Next is a cross account access. So like whenever any company is working on AWS, they does not have a single account. They have multiple accounts, right? Now assume that you have a company have a development account, a company have a testing account, and company have a production account, right? These are all the root account. Development is a root account, testing is a root account, production is a root account. Under the account, there are two different IAM users. So in development, there are two IAM users. On testing, there are two IAM users. In production, there are two IAM users. And there are some services. There are some resources in each account. Like in testing account, you have IAM users, you have a S3 bucket. In production account, you have IAM users in S3 bucket. In development account, you just have IAM users. You don't have any bucket over there. Now, if this user from a testing account want to access the S3 bucket, so how we can provide the access? Easy way. just create a policy and attach a policy to the user. So user can access this S3 bucket, right? But in the case when the user from the development account want to access this bucket, now these are two different root accounts. So resource is in testing account and the user it is in development account. My IAM user from a development account want to access the bucket which is in testing account. That time it cannot be managed by the single policy. So with the policy, you will need a role, right? So you have to create a role, you have to attach a policy to the role and attach a role to the user. Then only the user can access the other buckets, which is in other resources, which is in other account. That we call as a cross account access. Whenever you are dealing with multiple accounts and you want to provide a permission to the user to grant any service which is in other account, which is not in user you account, so that time you will need a role, provide a cross account access, right? So cross account access. For the cross account access, you will need a role again. Then for access provide for the identity providers. Now you had seen this logos multiple times for reading any blog, for accessing any website. They will provide you two options. First one, a login. Second one, sign up. And the human being are very lazy. So they don't like to sign up every time, right? They just want a simple way to access. So for that, this is the way it is called identity providers. Now, why we want to sign up? Because we want authenticated information of a user, like what is the name of the user, what is the email ID of the user, what is the birth date of the user, what is the location of the user, the cell phone number of the user, email ID of the user. So we need authenticated information. And for the authenticated information, you can just provide them a sign up page, right? So user can go over there, provide a sign up. You can just sign up the information and can access your blog or any other application. But there was a study, and as for the study, if you provide a sign up page to the human being are that much of lazy, you can almost 70% of human being will not sign up. They will just refuse to go over there. They will just close your website and they will search for any other website, right? That's the tendency of 70% of human beings. So they will not sign up, right? But in any case, you want to provide them some easy way to sign up. So that is this. Because all the people, because maximum people have the user account on Google account, on Facebook account, on Twitter, right? So they can use this account for signing up. So they don't have to sign up with a new account. They can use the existing Google account, existing Facebook account, existing Twitter account, and they can just sign into your website or your application, and then you use the services, right? So this can be provided by the role. Because after the sign in, you need to provide them authority. You will need the authenticated information from Google. You will need authentication information from Facebook, right? And for all this, doing all the kind of things, you will always need a role, right? That's the one thing. Other is the single sign-on mechanism. So let's say there are some your company employees. For them, you want to provide access. For the customer, it is okay to provide the google.com, facebook.com. But for the employees, it is not okay because there are millions of people on the Google and Facebook, and all are not your employee, right? So for them, you need other database, and the other database that we have is our maybe Active Directory, the Office 365, Google Suite, there's a G Suite, Dropbox, Salesforce, right? So these databases have the authenticated information of your company employees. So instead of using the Google, Facebook, you can use this authenticated information to provide access. So user can do a single sign-on. A single sign-on, like using the same credentials for the multiple databases. Just like if you're logging to the VPN connection, you will need a username and password. You can use the same username and password. Whenever you access any virtual machine, you will need the same username and password. You can use the same username and password, right? When you want to access your mails, you will use the same username and password. That you call a single sign-on. Same credentials for login, right? And same credentials you can also use on a AWS. So just link your AWS credentials with your on-premise Office 365 or G Suite or the Active Directory, and use the same credentials to log in on AWS as well. That you call a single sign-on mechanism, right? And this can be done with a role, right? So role, these are the four things that we can do: resource access, cross-account access, identity providers, and a single sign-on, right? Some of the additional features that the IAM have. So IAM have a feature of multi-factor authentication. So just like whenever you want to do some online transaction, so the bank sends a OTP on your cell phone or on your mail. So after putting your all credentials, you have to put the OTP as well. That is for the multi-factor authentication. If any case your bank details got leaked, so they still cannot do any transaction without the OTP that you get on your cell phone or on your email. The same thing like whenever you want to log in with a Gmail, a Gmail also send you a notification on your Android device or a OTP on your Android device, right? You have to put the OTP over there, then you can log in. This multi-factor authentication can be added to the AWS as well. So for adding the multi-factor authentication, you can use IAM. For setting up the password policies and password rotation policies, you can also use IAM. Like whenever user is setting up the password, a password must be of 8 characters. There must be some small letters, there must be some capital letters, there must be some special characters, some numbers over there. So for setting up these policies, IAM can help you to set up this kind of policies, or also password rotation policies. Means after every 30 days, the password must be changed. After every 60 days, password must be changed, right? For setting up this, IAM can help you. So IAM also have these features for the password policies and password rotation policies. Also for the policy generator, like we had seen policies, and not easy for everyone to create a policy in a JSON format, right? So for that, you can use a policy generator. So policy generator can help you to create a policy. This is a graphical tool, right? So use a graphical tool, you just click on, select your services, select your actions and click on create. It will create a policy in a JSON format and you can use that, right? So these are some of the additional features that IAM service have rather than managing users, groups, policies, and roles. Next thing, the best practices of the IAM to use IAM. If you want a high security, these are some of the best practices. First one, create an individual user, right? For every person. Don't share your credentials, right? As per the standard, you don't have to share your credentials, right? Create an individual user for every person, maybe a temporary, maybe a permanent credential, but create a credentials for every user. Second one, use a group to assign a permissions, right? So you can create a group for the every team, like for sales team, you can create a group for developer, you can create a group for Linux admin, you can create a group for storage admin, you can create a group for Windows admin, you can create a group. So create a group for every team member, for every team, and assign a permission directly to the group. Don't assign a permission individually, right? Grant a list privilege as you can. If any user wants a read access to the particular file, just provide a read access. If any user want a list access, only provide a list access. So first check out the role of the user. After checking the role of the user, provide a specific access, a list privilege to the user as you can, right? So that will be help you to improve your security. Always enable the MFA, multi-factor authentication, right? To the path, sometimes the password gets leaked and the leaking of the password, it is not a new thing, right? It happens multiple times, like a password get leaked online, right? So that for that, you must have to enable the MFA. If you enable the MFA, doesn't matter your password gets leaks or not. they still cannot log in with your password if they don't have the MFA with them. That's a multi-factor authentication. Always configure the strong password policies, right? So whenever user are setting up the password, they have to set up the right. So you will be rid of that particular shoulder suffering attacks, then the brute force attack. So anyone cannot do that attacks on your account, right? So always set a strong password. Always rotate your credentials regularly. If any case your password got leaked, if someone got your password, so in that case as well, if you're rotating your password after every particular time, so they cannot use your password after that particular rotation period as per your standards. It may be a 30 days, it may be 60 days, maybe 90 days, right? Monitor your activity in your AWS account, right? That is basically accounting part or the auditing part, right? So you have to monitor what the users are doing. If anyone deleted something, you have to check for who deleted that and why the person deleted that. If anyone created some resources, you must know why the person created the resource, right? So you have to notify the user like you did this thing, so why you did this thing. And for this, you have to monitor the AWS resources, right? That's the monitoring part, which is not covered in the IAM, that will be covered in next videos with the other services, right? So if you want to secure your AWS account, you must follow the best IAM practices, right? And this is the thing that we had seen for the IAM. First, what is the IAM? What the users? What the groups? What's the policies? What the rules? What are some of the additional features and best practices, right? So this was a basic theoretical overview of the IAM. So stay tuned. In next videos, I will show you some demonstration of the IAM, how we can manage the IAM on AWS, how to create users, groups, policies, and rules, and how to manage the permissions, the authentication, authorization of every user, right?